Hello everyone, welcome to part 5 of Me Learning Rust series. This is Rune Connor. So this part is about functions. Let's see. Functions are prevalent in Rust code. You've already seen one of the most important functions, the main function, entry point, the fn, the function definition keyword. Okay, Rust code uses snake case as a convenience style for names. Okay. All letters are lowercase and underscores separate words. Here's a program that contains an example function definition. Function main, print line hello world, and another function call. And then that function is defined here. Let me write that code. Just to practice writing code in Rust. Come from Python, so I do need the practice. Print line, macro, and then hello world. Semicolon, and then another function is called before it's defined, and this is the function definition. It doesn't take any parameters, open brackets, print line, whoopsie, and then another function. There we go. And we can run this by another function. What does that mean? What do you mean? Path statement with no effect. What path? All right, let's go to my project folder here. Projects. And then this is the variables project. I should probably change the project now to some other project. So cargo new functions. I'm going to change that to the functions project, just copy and paste that code in function source file. There we go. And now cd functions cargo run. There's a warning, path statement with no effect. Why is that oh yeah, forgot the actual function call, parentheses. Let's do that again, cargo run, and now it runs correctly. Let me do this. All right. We define a function in Rust by entering fn followed by a function name and a set of parentheses. The curly brackets tell the compiler where the function body begins and ends. Yeah, like that. Let me increase the font size here. We can call any function we've defined by entering its name followed by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function. Note that we define another function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define it, only that they're defined somewhere in a scope that can be seen by the caller. All right, so here the main function's body, this is a scope that can see the outer scope here. Okay. Let's start a new binary project named functions. Okay, I already did that. To explore functions further, place the another function example in source main.rs and run it. You should see the following output. Yep, we did that. The lines execute functions, nice. The lines execute in order in which they appear in the main function. First hello world, and then another function is called. Yeah. So first this is called, and then this is called, obviously. And when this function is called, you go into the function block and execute whatever is there. Parameters. We can define functions to have parameters, which are special variables that are part of a function's signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the words parameter and argument interchangeably for either the variables in a function's definition or the concrete values passed in when you call a function. Yeah, They are used interchangeably sometimes, but understanding the different difference between a parameter and an argument might be important. When you pass an argument to a function, if it's passed by a value, those values are copied into the parameter variables. Anyway, in this version of another function, we add a parameter. Okay, let's do that. Here you add an x parameter, x. It's an i32, signed integer, that is, 32-bit. The value of x is x. Let's type that. The value of x is at x. Okay. And then when we call that in main, the another function, we call it with an argument of 5. So let's run that. Cargo run. The value of x is 5 in our code, not in this code, because we passed the value 5 as an argument to the function, and that 5 was copied into this, into an address, and x started pointing towards it, and so on. Okay. The declaration of another function has one parameter named x. The type of x is specified as i32. When we pass 5 into another function, the println macro puts 5 where the pair of curly brackets containing x was in the format string. Right, so, and this is a format string, that, meaning you can use curly brackets here to print the values of a variable. So curly bracket x means find the name x from this scope and put its value in here. So what it did was put the value of 5 there, printed it. In function signatures, you must declare the type of each parameter. This is a deliberate decision in Rust design. Okay. Requiring type annotations and function definitions means the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. The compiler is also able to give more helpful error messages if it knows what types the function expects. When defining multiple parameters, separate parameter declarations with commas like this. Okay, like that. Print labeled measurement. Value i32 and then unit label character. The measurement is 5h. Okay, let's try that code. Print labeled measurement. Print labeled measurement. And then we got 5 as the value and h as the unit label. And then here I'm gonna rename this function to that. Value is i32 again. Okay, 32-bit signed integer, and unit label is char. And chars are, I think, 4 bytes, right? Unicode. Value unit label. Okay, the measurement is value, and then your unit label. Whoops. Let's run that. Measurement is 5h. There we go. This example creates a function named print blah with 2 parameters. The first parameter is named value and is an i32. Can I do this? Okay. I do not like this. Okay, there we go. The second is named unit label and is type char. Can I do this? There we go. Okay. The function then prints text containing both the value and the unit label. Let's try running this code. Replace the program currently in your functions project. I did that. Cargo run, because we call the function 5 with 5 and the value for 5 as the value for value and h as the value for unit label. Program output contains those values. If you're a beginner in programming, what happened was this argument 5 was passed into this value parameter when you're calling the function, and this h character was passed into this unit label parameter. So this is called passing by value, and these are positional arguments, right? You're passing by position. The first position goes to the first position variable, which is the parameter here, value. The second position argument goes to the second position parameter. Statements and expressions. Function bodies are made up of a series of statements optionally ending in an expression. So far, the functions we've covered haven't included an ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, this is an important distinction to understand. Other languages don't have the same distinctions, so let's look at what statements and expressions are and how their differences affect the bodies of functions. This is you have this distinction in C, I think. Statements are instructions that perform some action and do not return a value. Okay. Expressions evaluate to resultant value. Okay, I see. So statements are like void functions. They do something but do not return a value, whereas expressions are like value returning functions. We've actually already used statements and expressions. Creating a variable and assigning a value to it with the let keyword is a statement. Yeah. In listing 3-1, let y assignment operator 6 semicolon is a statement. Yeah. Function definitions are also statements. The entire preceding example is a statement in itself. Okay, so statements do something, but don't return a value, whereas expressions do return a value, evaluate to a resultant value. So 3 plus 5 is an expression, for instance. Okay, statements do not return values, therefore you can't assign the let statement to another variable. As the following code tries to do, you'll get an error. Let x, and then assign the resulting value of this would fail because there is no resulting value from this. When you run this program, the error you'll get looks like this. Expected expression found let statement. Found statement let. Let expressions in this position are unstable. Unnecessary parentheses. Remove these parentheses. Okay. Let y assignment 6 statement does not return a value. So there isn't anything for x to bind to. This is different from what happens in other languages, such as C and Ruby, where the assignment returns the value of the assignment. I think I like this better, what Rust does here, because I do not like the syntax that is generated from assignment statement, return values being used in algorithms. That's just not good for readability, in my opinion. In those languages, you can write x, assignment y, assignment 6, and have both x and y have value 6. That is not the case in Rust. Yeah, you can do this in Python as well. Expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates the value 11. Expressions can be a part of statements. Listing 3-1, the 6 in the statement, let y, assignment 6, is an expression that evaluates the value 6. Okay, so a literal is an expression that evaluates to itself. Calling a function is an expression. Calling a macro is an expression. Okay, a new scope block created with curly brackets is an expression. For example, that is it. This expression is a block that, in this case, evaluates to 4. Interesting. The expression itself contains a statement, though. This is a statement. That value gets bound to y as part of the let statement. Note that the x plus 1 line doesn't have a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions do not include ending semicolons. Ah, okay. If you add a semicolon at the end of an expression, you turn it into a statement, and it will then not return a value. Keep this in mind. Okay, this is an interesting detail. Okay, so if you want to use this as an expression that returns something, you should not use a semicolon there. Understood. And it will then not return it. Keep this in mind. Okay. Functions with return values. Functions can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow. In Rust, the return value of the function is synonymous with the value of the final expression in the block body of the function. So, like that. You don't need to use a return keyword in Rust, which I knew beforehand. You can return early from a function like using the return keyword and specifying a value. Yeah, so return keyword in Rust, in idiomatic Rust, is used when you want to return from a function early. The normal function return is at the end of the function, right, and without a return keyword. But most functions return the last expression implicitly. Here's an example of a function that returns a value. There. Okay. And that is the type of the return value. So an arrow and then a type specified here. And this function doesn't have any parameters. There are no function calls, macros, even let statements in the 5 function, just number 5 by itself. That's a perfectly valid function in Rust. Note that the function's return type is specified too. Yeah, arrow I32. Try running this code. The output should look like this. All right, let's run the code. Function before the main function is declared, you declare function 5. And then you get, all right, let's put a return value there, right, return type there, and the return value is 5. There is no semicolon there either, interestingly. I wonder if it won't return the 5 if you put a semicolon there. So let x assignment 5, all right, and then print line the value of x is x. Let's run this. Value of x is 5. The 5 in 5 is the function's return value, which is why the return type is I32. Let's examine this in more detail. There are 2 important bits. First, the line, let x5, shows that we're using a return value of a function to initialize a variable. Because the function 5 returns a 5, that line is the same as the following. Yeah. So instead of calling the 5 function here, if you just put a 5 there, literal, that's essentially does the same thing. Second, the 5 function has no parameters and defines the type of the return value, but the body of the function is a lonely 5 with no semicolon, because it's an expression whose value we want to return. Okay, so if you want to return a value from a function, you don't put a semicolon at the end. Okay. Another example. Let x plus 1, 5. All right, you take a value that's defined as the parameter x here, increase it by 1, and then return the evaluated result. Running this code will print the value of x is 6, but if we place a semicolon at the end of the line containing x plus 1, changing it from an expression to a statement, we'll get an error. All right, what's the error? mismatch types, is it? Expected I32 found nothing. Okay, that's the none type, the tuple. The main error message, mismatch types, reveals a core issue with this code. The definition of the function +1 says it will return I32, but statements don't evaluate to a value, which is expressed by this empty tuple, the unit type. Therefore, nothing is returned, which contradicts the function definition and results in an error. In this output, Rust provides a message to possibly help rectify the issue. It suggests removing the semicolon, which would fix the error. Wow, look at that. I love Rust. Great feedback. Remove this semicolon to return this value. Nice. So if you want to return a value from a function, you don't use the return keyword, and you don't use a semicolon. And you put the return value at the end of all the statements in the function. Okay. Let's see. Comments. I will continue with this in the next video.